Hello, Year 11. Welcome to our fourth video here. Quadratic functions. Quadratic functions, what do they look like? They've got an x squared term in them. Let's jump in and see what we've got here. So, if we express our quadratic function form, function of x, ax squared plus bx plus c, right, with coefficients a, b, and c, and we've kind of dealt with these a little bit before when we did polynomials, and we're talking about sum and products of roots, perhaps. Excellent. But anyway, if we do this, we get a parabola. Yeah, we'll sketch it. So a few things that we want to look at before we sketch it. We want to know, first of all, the concavity. I guess first we recognize that it's a parabola. Okay, we see the x squared and we go, it's a parabola. Then I look for the sign of the leading term. Right? Is it positive or negative? Because if it is positive, it's concave up. If it's negative, it's concave down. Right? Yeah. So that's easy enough. That's our first step. First of 5 steps I'm going to suggest for this method. Second, the y-intercept. Y-intercept's easy to find. Let x equal 0, same as we did with linear functions, you might remember. So let x equal 0, we find the y-intercept. That's pretty easy. That'll just be c, that'll be the constant. Then we look for the x-intercepts, and this is where life gets a little bit more interesting. Sometimes this doesn't work terribly well, but if I let y equal 0, then perhaps I can find the y-intercepts. Well, the thing is that not all parabolas cut the x-axis, but we're going to look at examples right now where they do, and in fact where they have, I suppose, rational zeros. Yep, so we can do that. So we find the x-intercepts, sometimes a little tricky, probably the trickiest part of the operation. The axis of symmetry is a vertical line, right, because parabolas are symmetrical. It is a vertical line. It will be exactly halfway between the two zeros. Now, we can average the two zeros. Having found them previously, we add them together, divided by 2. Right, that's halfway in between them, and that's our axis of symmetry. The vertex of the parabola is the last thing that we're going to need to sketch them following this technique. And the vertex will lie on the axis of symmetry. So if I substitute that x value, which is the axis of symmetry because it is a vertical line, substitute that x value into my function, then that will give me the y coordinate of the vertex. So to review, concavity, y-intercept, x-intercepts, axis of symmetry, and vertex. Those are the 5 things we're looking for. Righto. Oops. What did I do there? Something happened. Okay. Example 3. We want to sketch this. Y equals x squared minus 3x minus 4. Using this technique, the first thing we're looking for is concavity. This has a leading term of positive 1, I guess. So x squared is our leading term that has a coefficient of positive 1, so it's concave up. Second of all, second thing we were looking for was the y-intercept, the vertical intercept. Let x equal 0 and y equals -4. Cool. So we've got 2 things there, 2 of the 5. The next thing we're after are the x-intercepts. We find the x-intercepts, let y equal 0, and then we factorize, and we can, fortunately, fairly easily factorize that quadratic. And we get x minus 4x plus 1, which means the zeros are at 4, -1. Cool. So we've got the concavity, we've got the y-intercept, we've got the x-intercepts. Now halfway between 4 and -1 is our axis of symmetry. 4 plus -1 is 3. 3 divided by 2 is 1.5. Now I find when we're dealing with number plane things, when I'm sketching things, I prefer to have decimals than fractions. So there we go. My axis of symmetry is the vertical line x equals 1.5. Right, that's halfway between 4 and 1. Finally, we need to substitute 1.5 back into our function. So 1.5 squared is 2 1/4, minus 3 lots of 1.5. 3 lots of 1.5 is 4.5. 2 1/4 minus 4.5 is minus 2 1/4. Minus another 4 is -6.25. Again, I prefer decimals to fractions when I'm sketching. So there we go, my vertex is at 1.5, -6.25. Finally, we've just got to sketch it and label all of these things. Remember, I think a good idea to begin with by, move my head around while I do these things. I think it's a good idea to draw the curve first. not perfect, but you know, drawn on the screen, I struggle a little. Draw a nice clean curve first, concave up. Then put in your x-axis. I know I've got two intercepts, so I'll run it across here and label it at -1, 4. Then I get a fair idea where my vertical axis needs to go. And there we go. We've got these things. So my x and y axes go in. I label my y-intercept was at -4. My x-intercepts were at -1 and 4. My vertex, I've indicated this way, was at 1.5, -6.25, and that all lines up pretty well. And that is our parabola sketched. 5 steps, to remind you, 5 steps for sketching the parabola. Determine the concavity, up or down, depending on whether the x squared term is positive or negative. Find the y-intercept by letting x equal 0, that's the constant in the function. Find the x-intercepts by letting y equal 0 and solving that equation, hopefully, possibly. Find the axis of symmetry by averaging the two x-intercepts. And then find the vertex by substituting the axis of symmetry into the equation for the function. Rightio, that's it. I hope it made sense. I hope the exercises are okay. If you've got any questions for the video or the exercise, of course, please jot them down so you don't forget. And I'll see you in class.